Hello class. So today we're going to continue with logic gates, and like I said, we should wrap it up this week, but we probably won't get to the test this week, just because I want to get through a bunch of examples this week of everything you might see, and then we'll do the test probably on Monday. Okay, so the last thing we're going to look at for logic gates is how to construct logic circuits from Boolean expressions. Okay, so the very first thing we ever did with logic gates was look at the different types of gates and how to actually make some basic circuits, how to extract the Boolean expressions from those circuits, and then we looked at how to simplify Boolean expressions and how to evaluate expressions. So you should be able to now to take all that information and basically work through those expressions to create a circuit based on whatever the expression requires you. Okay, so that's pretty much what we're going to look at today. So a couple of little notes. The only gates you can use is AND or NOT gates. And remember, like the order of operations for Boolean algebra is a NOT gate always comes first, then the OR gate, then the AND gate, then the OR gate. However, anything in parentheses always comes first. So you work within the parentheses first, following this order in the parentheses, and then you follow this order for anything outside of the parentheses. Okay, so I got two examples we're going to look at today, just to kind of give you a basic idea of how to do this, and then we'll look at some more tomorrow. I'm going to do this one first, and then if you think you have kind of a little idea of how to do these, you can pause it and try this one on your own. Okay, so best way to do these is to first look at your example and see how many, so what you're looking for is the gates. So how many gates do you have? Okay, so we have NOT, that's obviously a NOT gate. Then we have inside parentheses A or B. So we have two operations that dictate there's a gate there. So our circuit should have, if we do it right, should have two gates. So which one do we do first? Well, you do what's in parentheses first. Okay, so that's just like how you were evaluating. When you go to make these circuits, you still follow that order of operations. So I'm going to do a or B gate. So now I have input A and input B, and those are going to go through a OR gate. Okay, then what do I have on the outside of the parentheses? A NOT gate. And it makes sense because a NOT gate, remember, can only have one input. Okay, so now just how I had you go through a circuit and write out the expression for each gate, you can do that to check it. Here we have A or B. Okay, and then here we have a NOT, whatever the input is. Okay, so this is not A or B. So if you notice, these were written by words. I just did that to kind of, give you a little bit better way of reading it. But most of the time, they're going to be written like this. Okay, but you might see it either way. Okay, if you want to try to pause it and try this one on your own, go ahead before I go over it. Okay, so we have X and Y, so that's an AND gate. Then we have Y and Z, that's an AND gate. And I have a OR here. So I have 1, 2, 3 gates. Okay, so which ones come first? NOT gate. I don't have any NOT gates to worry about. And then my AND gates. That's why I labeled this 1 and 2. Because these two, you work from left to right, but this one is an AND gate, so it's going to come before I do this one. And then my OR gate is last. So that'll be the third gate. So I'm going to do this gate first, then this gate, then that gate. Okay, so my first gate is an AND with an X and Y input. Okay, my second one is a AND with a Y and Z input. So there's a couple ways you can do these. So you can go ahead and draw another Y here and have them both run through it. Or you could do something like this Okay, so just like you were building the AC circuits, how you can, it's like a series, or in this case, this is like a parallel. It's kind of the same idea. It's like, but you still could just draw another Y down here if you want. Whichever way looks easier and simpler to you, doesn't matter. Okay, so now I do the OR game. The OR is between these two. Okay, so let's check that. Here we have X and Y. We have Y and Z. And here we have an OR, so it's that input or this input. Okay, and it's exactly what they want. Okay, hopefully that wasn't too confusing. These were just some very basic examples. As you can imagine, the expressions will probably get a little bit messy. So we'll start looking at a little bit harder ones tomorrow. These will just basically give you an idea of what's coming up. Okay, if you were able to do these, great. If you still need questions on these, just message me on Teams. Thanks, guys.